On page 431, we're going to start with our geometry unit. In 7.1, we're going to talk about nets and drawings for visualizing geometry. On page 431 in the gray box, it says, the essential understanding. You can represent a three-dimensional object with a two-dimensional figure using special drawing techniques. A net, vocab word number 1, is a two-dimensional diagram that you can fold to form a three-dimensional figure. A net shows all of the surfaces of a figure in one view. So in problem number 1, we're going to start by identifying a solid from a net. The net at the right folds into the cube shown beside it. Which letters would be on the top and on the bottom? So if you look at, for example, A, B, C, D, E, D's on the right, what letter would be on the top? It should be letter A. What letter would be on the bottom? It'd be letter C. What letter would be on the front? Letter F. So you have to be able to visualize what a cube would look like if you took its net and folded it up. So now let's look at the got it. The net in problem 1 folds into the cube shown at the right. Which letters will be on the top and the right side of the cube? So in the got it, we have the front as B. What would go here and here? If you took B, which is here, and that becomes your front, A would fold back, and C and D would fold back, E would become your top, and F would become your bottom. So the top would be E, and the right side would be C. On page 432, I want you to match each three-dimensional figure with its net and practice A on your own. You would find that number 1 is C, number 2 is A, and number 3 would give you B. In problem 2, we're going to be given the solid, but now you can actually use the net to draw the dimensions of the solid. And packaging designers use nets to design boxes and other containers like the box that we already talked about in problem 1. So for example, a cereal box. That's a perfect example of what a designer or someone would use to actually design the art, or if they're putting something around a box, designers use that and use the net to determine what they need to put on it. So let's look at A. If you're drawing A, we could start with the base of the solid. And if we labeled this, it would be 7 centimeters and 4 centimeters. If we unfolded the front and the back, that could look like that. Now these are only sample pictures. You don't necessarily have to cut it the way I am. So that would be 7, this would be 10. And then on both left and right would be rectangles. And that would be 10 centimeters and 4 centimeters. That is only a sample of the net you could draw. On page 433, problem 3 starts talking about isometric drawings. An isometric drawing shows a corner view of a three-dimensional figure. It allows you to see the top, front, and side of the figure. You can draw an isometric drawing on isometric dot paper. The simple drawing of a file cabinet at the right is an isometric drawing. A net shows a three-dimensional figure as a folded out flat surface. An isometric drawing shows a three-dimensional figure using slanted lines to represent depth. So on the got it problem, you have a stack of 3 cubes with a cube underneath. So there's actually 4 cubes in this shape. What we're going to do is actually just draw it. We're going to draw it ourselves and label the front right. So Here we go. Let's draw this thing. So I'm going to start with the top. So anywhere in your paper, start drawing the top. And then you just go from there and keep drawing until you draw the entire shape. This is just getting you to practice to draw three-dimensional shapes. So we're going to label the right side and the front. Now turn it over to the next page, on page 434, to practice A, number 6. Now we're going to redraw this one, however, this is going to be a little different. When you draw an isometric drawing, you actually don't show every single line that is shown in the original picture. So just watch me on number 6 first. Now this didn't happen in the Got It problem, and you're going to see why as soon as I start drawing. So on number 6, I'm going to start with the top again. Okay? Now, I'm going to go down 2 blocks. Here I'm only going to go down 1. And I'll explain this in a second what I'm doing. So I'm still drawing here, having fun drawing. I should have some music here while I'm drawing. All right, that's really bad. Okay, so you'll notice this part right here and this part. I didn't connect, for example, this line here, this line here, this line here. All of this is one flat surface looking at it from the front side. This side is on like the right side. So notice I'm looking at this from coming down. I didn't show the bricks because it's all one smooth surface. You only show when something changes. So like here, changes, goes down, changes, flat, changes. So let me finish the drawing here. You'll notice I didn't put in like all the pieces that go in here. This is an isometric drawing. So this is a front side, and this is the right side. It's kind of weird, but you just once you have more practice, it will be fine. On page 435, on problem 4, we're going to start talking about an orthographic drawing. An orthographic drawing is another way to represent a three-dimensional figure. An orthographic drawing shows 3 separate views: a top view, a front view, and a right side view. Underline those 3 things because those are what you're going to draw. Although an orthographic drawing may take more time to analyze, it provides unique information about the shape of a structure. So the Got It problem on page 435. Now I'm not going to draw it because it's what we just it's what we're going to draw out of your book, so you can just follow along on your book. We are going to draw 3 separate figures: a top view, a front view, and a right view. So the top view, we'll start there. The top view, if you look straight down from the top, and remember where the front is. So if you slit it back so the front's directly facing you, you're going to look down from the top, and it's going to look something like this. That's what the top is going to look like. If you look straight down from the top, notice the depth perception is not there. You're looking straight down from the top. Even though this piece right here is raised up higher than this piece and this piece, you can't tell it from this picture. All right, now we're going to do the front. The front, if you look at directly from the front, will look something like this. because once again, you have 2 blocks here, 1 block here, and 4 blocks here. The right side. The right side, if you're looking at it, it's going to have 1 block over here. And then we have 2 blocks going up. Whoops. That shouldn't be there. And then 1 block on top. And for some people, it's hard to visualize this. Some of you, you'll find it easy. So if you need more practice, pause the video and do practice A, number 8, on your own. And then, once you're ready, I will show you the answers to number 8. On number 8, that would be what your top, front, and right views look like if you drew your orthographic drawing.